It's not quite that fast. So basically, he was like, "Oh, that's all great." Like, that's really, I can probably challenge him. But I was like, I was there with Aqua. But it's control it with the Raspberry Pi. And by the end of it, like everybody was scrambling to I should have done. And I was like, I was just logging through and like 50 grand thing and scared him. No, he didn't. I would hope so. I really like on my
There we go. Okay, folks, we're going to go ahead and get started. I'm going to just introduce Andrew and Jacob, and their talk is Check That Certificate. Gentlemen? All right.
All right, good afternoon. Nope, sorry. Nice. Bad way to start the talk. All right, good afternoon. My name is Andrew Sorensen, and this is Jacob Jernigan. And today we're going to be presenting Check That Certificate, a project to make it easier for developers to communicate securely. So SSL, or TLS, is critical to the security of a large number of applications, including desktop applications, mobile applications, web applications, command line utilities, databases. They all use TLS or SSL to communicate with another system. And while a lot of research in SSL or TLS focuses on theoretical or difficult to exploit attacks, such as and have resulted in vulnerabilities such as Beast or Poodle, there's a whole entire class of vulnerabilities within TLS that are simple or easy to exploit. And these stem from a feature in TLS which is often considered optional by developers. However, it is completely non-optional and must be performed by the developer. So, unfortunately, certificate validation is an aspect of SSL or TLS that's often seen as optional. Raise your hand if you've seen a post similar to one of these, or working on a project, or attempting to get someone else's project to run. Okay, and now for those people, how many of you have, for example, taken one of these sample snippets and either used it to get something to work, for example, curl-k, wget --no check certificate, x509 trust store, right? And we've all used these things, right? But why do we use them? Well, we're trying to turn off a security control so we can get something to work, right? We don't have a lot of time to get our project to work, and we need to get it to do what it's supposed to do. And so what we do is turn off certificate validation. And it works, right? It always works. It does exactly what it's supposed to do. But what we don't notice is that we're potentially communicating with anyone, right? We've turned off a critical security feature of TLS. And when we do that, we subject ourselves to man-in-the-middle. So unfortunately, these type of posts highlight this problem within TLS, that if you have a security feature that can be easily turned off, well, someone's going to come in and do it. They're going to turn the feature off, and they're going to be vulnerable. So, as someone who does a lot of security or application security reviews, occasionally I'll come across software that uses TLS or SSL as a transport to communicate with a remote server. In fact, frequently, applications do this, right? More and more applications are communicating with a web service or an API, and they're doing that to perform some sort of sensitive operation on the back end. They might send credentials to the server. They might send data to process to a server, etc. All these use cases for it. Now, unfortunately, it can be difficult to determine whether an application actually does certificate validation. Now, it's easy to stand up a server and man the middle of the connection, but for an average developer, the tooling and time it takes to actually set that up and actually carry out the attack can be significant. And on the other hand, it's easy for an attacker to set this stuff up because they're motivated and they have the potential outcome of being able to obtain all the sensitive information sent on that transport. So, and let's just imagine that you find an instance where certificate validation is missing. Well, it's then difficult to tell a user or a developer how to solve that issue because, again, you run into those posts, right? You say, you do a Google search for how to do certificate validation in PHP, Python, C#, ... and you come back to a post on how to turn it off instead of how to turn it on, right? So you struggle with this thing, you don't know what to do with it, and at the end of the day, you end up turning it off, which is not what you want. And so, well, you have people on the kind of the quote on the top really illustrates this, right? So people who don't understand why it's necessary to do certificate validation. So the first quote came from a blog post that was providing details on how to turn off certificate validation. And so this user comes along and says, well, thank you very much. You solved the biggest problem of my project, right? It works now. I've got my code to work. It's communicating with, Google Maps API, whatever it might be, right? But they've completely turned off a critical feature of SSL. And they're happy about it, right? They turned it off. It works. Great. And then you've got the second class of people, right? That just don't understand what the impact of maybe turning off peer verification would be, right? So they've actually looked at the documentation here because they've got a specific option and argument that they're playing around with, right? This SSL verify peer thing. What is this, right? And so, well, they turn it off, and then they post on this discussion forum and say, well, as I understand it, you can turn this thing off, and curl will still communicate securely even though it doesn't verify the peer certificate, right? So there's something in there, right? There's something that they're not doing. What is it that they're not doing? Well, they're not checking their certificate. Now, what does that mean? Well, if you don't check who you're communicating with, you're basically using encryption, right? You're using encryption. You're still using encryption. You've always been using that. But you're not checking who you're communicating with, right? So I'm establishing a secure communication with so-and-so in the audience, right? But I don't know that it's actually you. It could be someone else. Anyone, right? Just so as long as they happen to be at the right time in the right place, I'm communicating with them. And I'm communicating insecurely because I'm not verifying who I'm communicating with. So when peer verification is skipped, the connection's only secure if an attacker can only intercept traffic, and they cannot modify. So they can only passively capture it. They don't modify it, then it's secure. But as soon as they can make any modification to it, it's done. The attacker can stand up their own server, you will freely communicate with it, and you'll share all of your secrets with it. Defeats the purpose of SSL. So, the focus of our research. As I mentioned earlier, a lot of research has been performed on kind of three different categories of SSL or TLS: design, cryptography, and implementation. A lot of research in those particular areas reveals kind of interesting vulnerabilities within SSL or TLS. For example, implementation, Heartbleed, right? Disclosure of sensitive information that's in the memory of the SSL server, right? That's a big deal. Or also the clients in certain cases. Cryptography, right? All the issues we hear about with RC4 to certain ciphers being bad, export ciphers, weak keys, all those sorts of things. Design considerations, right? Like, well, you designed your your protocol in such a way that it reveals information about whether the padding was incorrect or not. Well, okay, then you have a vulnerability. But in particular, we're most interested with this last category, which is using TLS, right? So TLS is complicated. You can screw it up. And if you don't use it correctly, particularly you don't do certificate validation correctly, you could be subject to a man in the middle. And then all of your security guarantees, all this stuff that everyone's invested all this time into developing becomes useless, right? It doesn't provide any security at all. So, two major areas of previous work that were notable for our research. The first one is a research paper published by the Stanford Crypto Group in 2012, and in this paper titled "The Most Dangerous Code in the World: Validating SSL Certificates in Non-Browser Software," they basically went through and evaluated a lot of different software packages to see how well it performed certificate validation. And it came back with some pretty devastating results, as you might imagine. For example, the Chase mobile banking application for Android, the PayPal SDK, and Amazon Payments SDKs do not validate the identity of the remote server. And when they don't validate the identity of the remote server, right, they're subject to man in the middle, which means that all that information that those clients were communicating with the server is now all subject to man in the middle, which is bad, right? Because we're trying to send sensitive information, and now it's potentially disclosed. And while this paper was really focused on solving specific instances of the problem, there's another project that kind of took it a step further. So this project from ISEC Partners, another consulting group, basically what they tried to do is they put together examples of how to use SSL or TLS correctly. In particular, they focused on certificate validation, right? It's the problem at hand. Problem that we're most interested with. Now, unfortunately, they were really limited by the number of examples that they had in their code base to work with. So they only had an example for C in OpenSSL, which is a difficult one that people frequently mess up. And then they also had one for iOS and Objective-C, which is also helpful. But again, it doesn't encapsulate all those other cases where people do certificate validation in desktop or mobile applications and would need an example of how to figure out how to do it. So now I'm going to hand it over to Jacob to talk about some of the specific areas where people kind of confuse or misuse TLS.
Okay, so, excuse me. So Andrew talked a lot about the developers and their knowledge, but what I'm really going to focus on is libraries, because as I'll talk about in just a second, libraries either have incorrect documentation or what we've kind of dubbed obscure implementation flaws, where the library will do one thing, but the documentation says it does something not completely different, but different enough that it could be a problem. So TLS is often a checkbox on an application security feature list, right? So I have TLS enabled and we're good, except obviously we know that that's not necessarily true, because we need to make sure who we're talking with, along with some of the other issues that are outside of the scope as far as ciphers and things like that. Please excuse the pun, but outside of the scope, trust and key management are key failure points in cryptography as well. Had to include the terrible puns somewhere. So, understanding the complexity. Certificate validation is extremely difficult, especially because certain libraries effectively leave it up to the user. WordPress is a good example of this, where you have PHP and WordPress had to write their own certificate validation because the one in PHP is kind of hard to use. And the problem with that leads into edge cases like non-standard characters like Punycode domains or wildcards, and you have to account for those and all of the failure cases that could come with that. What that leads to is larger projects can often, like WordPress, get it done, but smaller projects either don't do it because they don't have the resources, or they do it incorrectly or non-feature complete because they just don't have the resources. So a good example of the documentation not fully explaining the ramifications of an option would be wget. So the wget option CA certificate, in the man page, you'll see without this option, wget looks for a CA certificate at the system specified location. What that does not tell you is that it also uses the system trust store. So if you're not expecting to use a system trust store and only passes CA certificate that you have specified, you're going to run into a problem. And an example of this would be like if you have a Lenovo laptop vulnerable to Superfish, and you don't want to use that certificate, and you try to use this option, it's not going to work. So .NET is a really interesting bug. If you look at the .equals method for an X509 object, which is your kind of default object for SSL or TLS certificates, you'll notice in the the documentation that says very specifically 2 X5 objects are considered equal if they have the same issue and serial number, that should make you very afraid. Unfortunately, in the remarks, there's nothing about the cryptographic security of that, and you actually have to look at the Windows API, the underlying calls for that from the .NET to find that that's insecure. So if you don't know that from reading this line, you can use it, and we've actually found a few projects where that had happened. Unfortunately, if you happen to know that a project is using this to validate a certificate, you can easily create a third certificate that you can use to man in the middle. So Python, the HTTPS connection class does not perform validation by default in certain versions. Most of the newer versions they do, but anything before 2.7.9 I believe does not. The problem with this obviously is that you'll never know, because if you don't get an error in development, you'll just ship the code, and as a user, if you expect it to be secure, you have no idea until you read some documentation eventually, hopefully, and find out that it's not. So OpenSSL, this was an interesting that we kind of tossed around whether to include or not, but as client very specifically mentions that it's a test tool, but we found a couple of pieces of critical software, that specifically a VPN client, that actually use it to connect to the VPN server without validating the peer. So obviously newer versions of SSL as client do include an option to validate your peer, but these particular pieces of software we found did not use that. So even when the library is correct, working with TLS is still hard, as we've kind of tried to talk about. If you're working with internal servers, you have to try and roll your own PKI and manage not only that with the ramp-up time, but you have to try and securely distribute your CA files and manage all of that across your network. Obviously, there are tools for that, but that's a significant amount of ramp-up time that a developer just might not have. So local development, let's see. So the other interesting case that I like is time. So if you're not managing time on your server or on your client, you could possibly run into a failure case where a certificate is either valid or invalid because you're within the window when it really shouldn't be. So, as we like to do in security, let's go ahead and blame the developers because it's just all their fault. But is that really fair? Because, as we've seen, the documentation is either limited or incorrect. The need to perform validation isn't clear to a developer if they don't know anything about TLS. And to be honest, if you consider when you're trying to ship some code and you're not aware of the security implications and you just have to get it done because it's due at 5 o'clock on Thursday because you can't ship on Friday, so it's got to be ready for Monday, let's just disable verification because it just has to be done. So I'm going to go ahead and pass it back to Andrew for the conclusion.
All right, so in conclusion, right? This certificate checking is a really difficult problem, right? And developers often run into issues with it. And their first instinct is to turn it off because, well, you don't see an easy path out to do it correctly, right? And so your only option is to just turn it off and proceed along, right? Well, that shouldn't be the case, right? So let's try to see what we can do to fix that. So what we did was we took the approach, similar to ISEC partners, to write documentation on how to do things correctly. And while we're still vetting kind of our examples, what we're doing is we're going through and looking at all these different libraries and frameworks and trying to write code that would actually do certificate validation. So, right, as a consultant, frequently I review applications that need to do certificate checking, and I always have this struggle with needing to be able to provide a recommendation that someone could take and or act on, right? So they need to be able to have something that a normal developer, not a security person, not someone who understands TLS completely, can take and implement certificate validation, right? So they shouldn't be dealing with things like host name verification, writing that themselves, peer verification, how to deal with bundling certificate authorities with your system. If you're running like a Cygwin compiled application on Windows, right, where you don't have access to the trust store, all those sorts of things. So what we wanted to do is make it simple for developers to do certificate validation. So we created these examples. PHP, Python, C#, and Ruby are some of the things that we're starting with, and a couple of those standalone tools that we described earlier, like wget and curl. And we're essentially making a website. It's still in the process at this point, but you can certainly look at it now, to give people a place to do the right thing. So instead of in the future, instead of those Stack Overflow posts that tell you how to turn it off, and they're always the upvoted answer is always, well, if you just do no check certificate, you'll be fine and dandy. And then someone will follow up and say, well, thanks, it's great, it works. Instead, there'll be some really clear directions that will say, well, the first thing you need to do is identify who you need to communicate with, and then you get the certificate for that machine, right? And then dealing with all the formatting issues, abstract that from the user, and then this is what you do. You take the certificate, you bundle it with your application, right? You do certificate pinning, and you can use those self-signed certificates, right? You don't have to go through your IT admins that to do test work on your own machine. So instead of turning off certificate validation, you can roll your own certificate locally. And if you're shipping a mobile application, you can do certificate pinning in your mobile application. And instead of relying on the trust store, right, when you don't need to trust a whole bunch of extra parties to vouch for your certificate, well, since you already have it bundled with you, well, you just trust just the host of the machine that you need to communicate with, right? So we solve a lot of the issues with certificate authorities. We solve some of the issues with having to deal with setting up your own PKI. And we get to the point where you can just look at an example and you can implement it in your application. Are there any questions?
What about certificate validation PHP?
Can we ask them to go to the mic?
So the question's about what about certificate validation in PHP. So PHP is an interesting one, right? So before 5.6, there's host name verification, something that you have to implement by yourself, and a bunch of other details. Some of those cases are a little more difficult for us to work through, and since we're trying to work with a bunch of different languages, the thing is I'm going to direct you to this next slide, which says, to follow up with those PHP problems by, if you want to help, sure, let's do it, right? And certainly there's a lot of people that rely on PHP, and they should be able to communicate securely. That's totally a goal. We don't want to discount a language just because it's difficult. We want to have a recommendation. Other questions?
So you mentioned in your research that you came across a lot of documentation like wget and curl and stuff like that was either misleading or incorrect. So as part of the website work, which is awesome, are you actually going back to those projects and stuff and committing and saying, hey, we need to update this doc, or here's a change list with these docs and things like that?
Right, yeah. So the question was more about you've got findings, right? So what about reporting those back, right? So we've been working with some of the parties, for example, Microsoft. We worked with them to identify kind of where the issue was within the documentation, what kind of a best approach would be for fixing it. For the others, sometimes there are open bugs that have been open for many years, like the S-Client bug. There was a little screenshot back in there that said it actually been open since 2003 in bugs.debian.org, right? So, 12 years later, we finally got a fix. Actually, it was fixed in 2014. So 11 years later, we finally fixed this issue of getting certificate validation going. Python, right? It's been fixed, right? It's been fixed in the language. The problem is not so much the language needs to update. It's just that the supporting documentation around, like examples of how to do it or sample code, is incorrect. Does that answer your question?
Yeah, thank you. And also curious. You mentioned Stack Exchange, and there's so many bad examples. Like, is part of the effort going to be to troll Stack Exchange when people ask these same stupid questions, or not stupid but valid questions over and over, like, hey, here's some good examples, right? Because people are not going to go to Stack Exchange because then nothing would ever get coded.
So I'm actually good friends with several of the sysadmins for Stack Exchange, and I think they would murder me if we did that. So I think as time comes, we'll try and update some of those where we can. And to be fair, we didn't talk about it, but on several of those posts, there are answers that say, do not do this, please do this instead. Unfortunately, they're the hard answers, and the easy answers often get upvoted because people, oh yeah, I'll do this, and it works, right? So we should be fair and say, it's not all bad, but most of it is.
Cool. Thank you.
Yeah, and just to sum up on that note, I think the other thing is that Stack Overflow and these other posts are kind of collaborative in nature, right? So there are things that can change over time. I think as a project or any project that kind of attempts to do this, right, provides more accurate and easy information, right? To some extent, that will kind of trickle up, right? People will get the right answer. Front row?
So depending on which language you're looking at, sometimes it's a lot more or less work, as you said, to get this right. Have you considered, in addition to just providing examples, providing libraries in these languages to actually make it as simple as possible for people to do the right thing?
Right, so the question was essentially, not only would you consider developing examples for particular languages, but what about just in improving or wrapping those libraries around with some other library to make it even easier. I definitely see a value to that, right? To some extent, the question of who should write those libraries and whether they should be included or not in the standard library is something that would be worth considering, right? I don't really want to see people need to download, yet another library to do cryptography, right? Like the idea of someone needing to download Bouncy Castle or some other, alternative SSL library in Python or PHP or any of those other things, to me, is not very valuable because there's still going to be people who have their own version of those things, right? But certainly, yeah, I can definitely see a value to doing that. And maybe once we got the rudimentary issues solved, right, the first level things, the things that you have to interact with in the library, certainly wrapping those things up into a simple class or something like that a developer could take and replace to override existing functionality within the language to make it secure by default. That's definitely valuable.
So we actually did something very similar to that in our .NET example. I think that one of our concerns was we want to make sure that we're giving people secure code. Like, we don't want to give you something that's now vulnerable. So we want to be extremely careful about what we publish. So we're looking at that very carefully.
Yep.
One solution would be to GitHub and have a few other experts.
Yeah, so that's definitely an option. You can go on there. We actually definitely want you to do that. So you can go to the website and get to GitHub and tell us we're doing it absolutely wrong, and this is how we do it right. Please do that, because that's what we're looking for. We want to help people. So yes, definitely do that.
Right. The whole goal here is to make this something that people who are experts in can get involved in, right? Right now, it's a lot of the same people posting who don't know about this topic that are posting back and forth about how to turn it off, right? So we want to change the conversation. Next question.
Have you guys looked into the quality of code that you're examining and their use of CRLs or OCSP servers for validation? Because I didn't see either of those terms mentioned.
Right, so the question there was more about CRLs or OCSP. So to us, certificate revocation is kind of a less interesting case of certificate validation, right? Because most of those systems, to some extent, work on the principle that you have to download a CRL, which is subject to denial of service, and in that case, the CRL won't be checked. Since we're kind of focused on certificate pinning in particular, that also makes it a little bit less interesting. But certainly, that is a highlight of our project. And if you go to our main page, it lists that as on the kind of the criteria for writing example code, just to be able to check the CRL.
Just a quick note on that. One of the big things that we're working with is this is to try and help folks that are trying to test their applications, so they may not need to work with that yet. I think our hope is that somewhere in the organization that there'll be somebody who will help them change these things for production, right? So I think there was one more question. Nope. Okay.
Okay. We're just about out of time here, but if you want to have any other questions for us, we'll be hanging out in the chill out lounge just a couple of minutes after the talk. So thanks for coming.
Yep. Thanks, guys.